Hello everyone.
Hello.
Today we're going to be solving one and two step single variable linear equations.
And we'll wait for the slide to click to the next one, which may take anywhere from 3 seconds to 3 minutes.
Da, 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 da. All right. What does it mean to solve an equation? You know, you got to look at like a good detective movie. There's lots of good detective movies out
Love
there.
them.
There's
Great.
some good TV shows too, all right?
There are.
NCIS and
Yeah.
CSI, Sherlock Holmes for the old school.
Why not, right?
Maybe some new school too, but mostly maybe that's old school. You got to find the truth. You know, solving an equation really means finding out what's going to make it true. That the right side's got to equal the left side.
Or the left side has to equal the right side.
That's very true, actually. Here's a good example for you. We have a problem, 3x equals 12. So what would x have to be so that the right side is equal to the left to make the equation true?
Well, I would say the left side has to be 12 as well.
That's true. So how are we going to know that? We got 3x equals 12. What process are we going to use in order to get this to make sense?
It's a really, really great question, Mr. Reitman. Oh, and by the way, I'm Mr. Bridges for those of you not in our class.
Oh, yeah, and I'm Mr. Reitman. That's okay.
Well, that's what we're going to explore today. Oh, but it tells you the answer right now anyway.
It does. It does. So x equals 4. And so we can then put a 4 where the x was and say 3 times 4 equals 12. And there's a beautiful pop-up here right in the middle there. So then we know that 12 equals 12. Isn't that great?
Wonderful.
Makes things simple. Let's move on to our next one. This is going to be about solving single variable linear equations.
So just like the last one that we saw, you could guess and check, you can use intuition. Some of them are very, very straightforward. 3 times 4 is 12. And that strategy works pretty well for nice ones, especially ones that you might have seen before and everything else. Our goal to all of this, when we're trying to solve it, is, of course, what makes the equation true, and we do that by isolating the variable.
So let's look at solving one-step equations. We have a problem, x plus 5 equals 12, and we want to find out what x is. Now you might be able to look at this right now and say, oh, come on, I got that easily. But we need to show you the steps to make sure you really understand it. So how do we cancel the addition? We cancel addition by using its opposite, which is actually subtraction.
Wow.
So far, so good. So if we subtract 5 from the left side, we've got to subtract 5 from the right side. Okay? So I'm a step ahead here. We must do the other. So in order to, whatever we do on the left side, we've got to stay equal and do it on the right side.
Think of it like a balancing act here. If we do something to one side, it goes way up. And then the other side's got to do something, we got to bring it to that level. And again, that goes back to our first kind of take when we talked about what makes it true. Well, we got to keep the sides balanced. And then, of course, we get 7, which some of you are probably thinking, yeah, I knew that an hour ago. It is what it is. All of these properties that we're going to go through, and I'll just kind of punch them up right now, the concept of doing the same thing, it's all about properties of equality. So if I add to one side, I got to add to the other. And subtraction, same thing. If I'm subtracting one side, I got to subtract to the other. Multiplication, division, they all work the same way. It is trying to keep it consistent and fair and that whole balancing act that we do. Left side has to equal right side.
One moment for a technical difficulty.
Keep getting pop-ups.
So here's an opportunity for you right now to solve these equations. And let's see what you guys come up with. We're going to give you a couple minutes here to figure this out. So ready, get going now.
You should probably pause. And pause. And we're back!
Well, let's see what you guys came up with here. Here are the correct answers for the first one, x equals 33, because we have to add 12 to the right side. And if we do that, we're going to get 33. We have to divide in this second problem, so 2x equals 50. If we divide both sides by 2, we'd have 25. In step 3, we have to multiply both sides by 5 to get the x by itself, so we would have 35. And then for number 4, we'd have to multiply Okay, both sides by 3 to get x equals 27. Hopefully you guys got those and we're off to a good start.
The next step is to add another step, right? So we go to two-step equations. Now this one looks a little bit different. And again, at this point, now you're starting to have to use the process of isolating the variable. The 2 is attached with the x, so that is what we're going to save for the end, whatever's attached to the variable. So to get x alone, we need to cancel the subtraction first. Some of you may think, I got to another way to look at it is doing the reverse of order of operations. So instead of multiplying or dividing first, we're actually going to add or subtract first. So we're going to get rid of the 7 first. How do we get rid of subtraction? We need to add it to both sides. So we add it to both sides, and then to get rid of the 2x, the 2 in front of the x, since they're being multiplied, we would divide. So we add 7 to get 20, divided by 2 to get our answer of 10.
And it's always a good idea to plug numbers back in when you're done, just to make sure you have the right answer. Just because you did the steps, you have to make sure that you have everything correctly.
And that is verifying your solution.
Right.
Boom, plug 10 in, see if it works. Notice 13 equals 13. The left side equals the
Right side.
wow, and the right side equals
The left side.
awesome. Math is cool.
So here's some more opportunities for you guys to work on the two-step problems here. So look at them, take a couple minutes, and now would be a good time to pause. Welcome back. Let's see how you guys did. Problem 1, we took away 25 from the left side, put it on the right side. 5x equals 75 and x equals 15 when we divided both sides by 5. Number 2, we started with a negative problem. We had negative 2x minus 52 equals 6. Negative 2x equals 58 because we added 52 to the right side. And then we just divided, and we got x equals negative 29. For number 3, same thing. We added 4 to both sides to give negative 4x equals 20. Divided both sides at that point by negative 4 to get x equals negative 5. And in problem 4, we had negative x plus 15 equals 33. So we subtracted 15 from both sides, negative x equals 18, and just flipped it around to say x equals negative 18.
Well, that's all, folks. I hope you had as much fun as we sure did.
We definitely did. Thanks very much. Hope you guys learned something. If you have any questions, please review this at any time. Thank you very much. Have a great day.
Goodbye.